Welcome back, everyone. Now, in this video, we're going to talk specifically about polynomial division. In the next video, I will do binomial expansion, but for the sake of this video, I'm just going to do polynomial division. So, when looking at polynomial division, as you've probably seen before in your Algebra 1 or even Algebra 2 days, so it's always possible to do long division with polynomials. Now, when we're dividing by a linear function, it's going to be beneficial to know how to do synthetic division. Now, I will say for AP Pre-Cal cases, it's not required to know, you're not required to know synthetic division, but knowing synthetic division and using it when possible it can be such a game changer because it can save you a lot of time and it can even save you a lot of headache. So we're just going to kind of dive right into dividing. So looking at this first one, we have polynomial division set up as a rational. Now what we're going to do is you need to look to see what we're dividing by. In the top, we're going to have your dividend, which is what's going to go on the inside of your hypothetical little division house. And on the bottom, you're going to have your divisor. Now, this is what's going to go on the outside. So when you do your little division house, you're going to have your dividend written on the inside and your divisor written on the outside. And then your result will be the quotient that's going to be on the top. So when I look at my division here, I can see in the divisor, I'm dividing by a linear. So with that tells me I can actually do synthetic here. So when you do synthetic, you're going to take your divisor and you're going to set it equal to 0. So I'm going to do x minus 2, set that equal to 0, and that's going to give me a solution of positive 2. So that 2 is what we're going to do, or use rather, for our setup in synthetic. So my setup is going to look something like this. So the number that we get when we set the divisor equal to 0, that's the number that you're going to write in this little corner over here. So I'm going to take that 2, just as is, write it over here. And then across the top adjacent to that 2, you're going to be writing the coefficients only of your dividend. So you're going to be writing the coefficients of your dividend right across. Now when I say the coefficients, they have to be in descending order. And then you will possibly need to fill in any 0 coefficients as needed. So looking here, I have x to the 4th, which means I'm going to have a coefficient of positive 1, and then a negative 6, and then we have a positive 13, a negative 11, and a positive 5. So those are the corresponding values I'm going to write across for synthetic. So I'm going to get rid of these. Now I can begin synthetic. So with synthetic, the first thing that you're going to do is you're going to bring down this first one right here, the first coefficient, and I'm just going to write it as is. And now when you're looking at the value from the divisor and the value you are bringing down, these values you're going to multiply. So I'm going to do 2 times 1, which is going to give me a value of 2. And then when you're looking at the values vertically like this, you're always going to add them together. So negative 6 and positive 2 is going to make negative 4. And then I'm going to move over. Now 2 times negative 4, which is going to give me a negative 8. And then we're going to add these together, which 13 and negative 8 is going to give me 5. Now you're going to multiply 2 times 5, which is going to give you 10. Add negative 1, multiply negative 2, add, and you get 3. Now what's going to happen, your very last value over here that you get, I'm also going to box it off, and this is going to be your remainder. And then as you move along, these values are going to increase in power, and what this tells you are the coefficients of your quotient. So what I'm going to do is I'm going to rewrite this as 1x cubed minus 4x squared plus 5x minus 1. And then, in order to write your remainder, we're going to write this in a specific format. So if you look back at the directions, which I skipped over, unfortunately, my bad. So we're going to write your answer using polynomials, but we're going to write it using the division algorithm. So this form right here is what we call the division algorithm. We have the quotient, which is your answer, multiplied times the divisor, and then you're going to add your remainder. So this is going to be the general setup for AP. So over here, my quotient, which is what we just got as the answer, so I'm going to rewrite this as x cubed minus 4x squared plus 5x minus 1, and I'm going to multiply that quotient times the divisor, which the divisor in our case is x minus 2. So then times x minus 2. And then you're just going to add on your remainder. So your remainder is just going to be your 3 that we got on the very end, and I'm just going to tack it on at the very end. So this right here, this is what your answer will look like for these. Ta-da! Now if I look over at number 2, now if I look at my divisor over here, I'm seeing I'm dividing by a quadratic. So just something that's nonlinear. So when I'm dividing by something that's nonlinear, that tells me I will need to do long division. So I'm going to go ahead and set up my fancy little house. And then I'm going to write my dividend on the inside of that house, but it has to be in descending order with any 0 coefficients as needed. So I go from 3, 2 to a first power to a 0 power, so I'm already in descending order when it comes to polynomials. So I'm just going to copy it as is. So 2x cubed plus 13x squared plus 19x and plus 6. And then I'm going to rewrite my divisor on the outside over here. So x squared plus 5x plus 2. All right, so what I'm going to do is now, I like to think of this as kind of like a Mean Girls reference. So we only care about Regina. We don't really care about the Karen and Gretchen, meaning we're going to focus all of our attention on the leading coefficient. So we're going to look just at these leading terms. So I'm going to focus on my Regina. We don't really care about the Gretchen and Karen over here. They're important, they're part of the clique, but they're just going to kind of follow along. But we're not going to pay too much attention to them. So what's going to happen is I'm going to do x squared times some value, and that's going to give me 2x cubed. So x squared times 2x will give me 2x cubed. So now what I'm going to do, I'm going to take this term that I just got, and I'm going to multiply it times the entire divisor, and I'm going to write it underneath right here, and then what I'm going to do is subtract that result. So 2x times x squared is going to give me 2x cubed. And then 2x times 5x, well, that gives me 10x squared. And then 2 times 2x will give me 4x. So now I have that result. I'm going to write this in parentheses, and then I'm going to subtract these values. So it's so important that you have the parentheses here, because I'm not just subtracting the 2x cubed, I'm subtracting the whole value. So what I've seen some people do is they go ahead and just distribute the negative. So if you want to do like a negative 2x cubed, negative 10x, and a negative 4x, and then add them together, that's also perfectly fine. Just be careful with your setup. So when I do my subtraction here, the leading terms right here, they should always zero out. So this should always go to 0. If it doesn't go to 0, then that means you need to go back and reevaluate what this value is. So when I do my difference, these are going to go to 0, so those are gone. And then I'm going to look at 13x squared minus 10x squared. So that's going to give me 3x squared. And then I'm going to do 19x minus 4x, which that's going to give me 15x. So that was what I call the first cycle. Once I finish that first cycle, then I'm going to bring down the next value in my dividend. And then I'm going to repeat that same process. So once again, we only care about the Reginas of the group. Gretchen and Karen, they just follow around. So I'm looking to see x squared times some value is going to give me 3x squared. So I've already got the x squared accounted for over here and over here. So all I need is this 3. So then that's going to be, come back. My values keep going away. 6, come back. So I'm going to do plus 3. Now I'm going to take this 3, the 3 only, not the 2x. We're done with the 2x. I'm just going to take this 3 and multiply it times the divisor. And then once again, I'm going to write it underneath over here. And then I'm going to subtract. And then we're going to get whatever's left. So 3 times the divisor is going to give me 3x squared. And then 3 times 5x, which is going to give me 15x. And then 3 times 2, which is going to give me 6. So luckily enough, what I notice here is everything's going to cross out, so we have nothing left, which means we have no remainder. So we're still going to write your answer in terms of the division algorithm that's up here. So as I mentioned, this is called the division algorithm. All right, so when I write it using that division algorithm, so that means I'm going to have the quotient, which is going to be 2x plus 3. And then that's going to be times the divisor, which is x squared, that's a squared, plus 5x plus 2. And then we don't have a remainder, so you don't have to write it out. So this would be your answer. Okay, I'm going to fill this in, style, fill, and highlight. There we go. So I'm going to do the same thing over here. Style, fill. There we go. Ta-da. All right. So that's kind of a brief synopsis or a brief recap of long division. So down here, it's the same idea, but we're going to kind of step it up a little bit. So now instead of writing it as a rational, now we actually use the division algorithm and we give you the components. So I'm telling you that some polynomial, which is p of x, is going to be equal to a divisor times a quotient and some unknown remainder. And we're going to figure out what the quotient and the remainder are. And then we're going to write it using the division algorithm. So if you want to rewrite it as a rational, that's totally fine. You can. So when you write it as a rational, this would be on top, and then this would be on bottom, if you want to write it out that way. So if you really wanted to solve it, so p of x equals q of x times d of x plus your remainder, which is r of x. So we don't know if we're going to have some sort of remainder, so I'm actually just going to pretend that this isn't here. So just in general, lost my train of thought. Here we go. So just in general, we're solving for the quotient, which means here I'm going to divide by whatever the divisor is. So if I divide by divisor, which is d of x, that means, whoops, this should be all the way across. There we go. So that means your quotient is equal to the polynomial divided by the divisor. So it's the same thing, it's just a different setup, but this follows the same mechanics and schematics as what we did above on both problems. So that one and this up here. So this is just kind of food for thought. So over here, now I'm going to look at the division. So I can see I'm dividing by a linear, which means I'm going to go ahead and just do synthetic. So I'm going to take my divisor over here, set it equal to 0, which is just going to give me x equals -2. And I'm going to go ahead and set up using synthetic. So I know I'm going to have -2 in this far left box over here. And then I'm going to write my coefficients. So I'm going to check to see if I'm in descending order first. So I go from a cubic, squared, linear, and then I have a 0 power. So I go 3, 2, 1, 0. So I know I'm good. So my coefficients are going to be 2, 7, 10, and 15. So now to begin, I'm going to bring down this first value. So we have this 2. And then once again, if we're going kind of diagonally, that tells me I'm going to multiply. So -2 times 2 is -4. When I look vertically, that tells me I'm going to add those values. So 7 and -4 is going to give me 3. Then now I'm going to look diagonally, so I'm going to multiply. So that's going to give me -6. We're looking vertically, so I add, which gives me 4. Working diagonally, so multiply, which gives you -8. And then working vertically, which means add, so I get +7. So down here, this will be my remainder. So once again, I have remainder, and then I'm going to increase in power. So when I write x to the 0, I've seen some people, whoops, come back. What I've seen some people do instead of x to the 0 power, you can write a c for your constant term. It means the same thing, but I think writing x to a 0 power, I think is more mathematically correct, but it really is just up to your own preference. Okay, so when I write, I'm going to write my quotient. So my quotient is going to be 2x cubed plus 3x plus 4. So I'm going to have 2x cubed plus 3x plus 4, and then I'm going to multiply times the divisor, which the divisor they tell us is x plus 2. And then I'm going to add on that remainder at the very end, which is 7. So this would be your quotient, or rather your polynomial. Okay. Now number 4. So this is where we're going to kind of start getting into the little tips and tricks. So over here, what's going to happen is, notice how your dividend here, or a polynomial rather, which I guess is your dividend. So in this case, it's not going to be written in descending order. So when you do, well, neither is your divisor over here. So when you do polynomial division, it is so crucial that you write your polynomials in descending order. So you're going to start with the highest exponent going to the lowest exponent. So I'm dividing by a nonlinear, which means I need to do long division. So I'm going to set up my fancy little house. So when I write inside my house for my dividend, I'm going to have x to the 4th plus 4x cubed minus x plus 1. And then my divisor over here, so x squared minus x plus 1. All right, now we're ready to do our long division. So once again, we're only going to look at our Regina Georges. So x squared times what is going to give me x to the 4th. So we're looking at these values. So I need an x squared. So now I'm going to take that x squared, and I'm going to multiply it over here times my divisor, and I'm going to write it underneath, and then we're going to subtract that value. So when I multiply, we get x to the 4th minus x cubed plus x squared. Okay, and then we're going to subtract. So x to the 4th minus x to the 4th, thankfully those will cross out. So then 4x cubed minus negative x cubed. So 4x cubed minus negative x cubed, that's going to turn into addition. So that's going to be 5x cubed. So I would say right here, steps like this is where I see the most mistakes happen. Because when you're subtracting a negative, that's going to turn into addition. Okay, and then I also see people mess up this next step. So negative x minus x squared. Whoops, I forgot my x squared up here. Oh, my bad. I actually messed up this a lot. I'm so sorry, y'all. Okay, so my dumb self did not take my own advice. So over here, we go from a 4th power to a 3rd power, but I don't see a 2nd power anywhere. So what that means when I do my dividend, I'm so sorry, y'all. Okay, so this is going to be x to the 4th plus 4x cubed. And then what's going to happen is, because I don't have that squared term, I need to include a placeholder, 0x squared. So I guess really my last attempt wasn't in vain, because you can kind of see, like, if I were to try to do that subtraction on this step, I was trying to compare an x value with a squared value. And when I try to combine those, it doesn't work. So I guess the last attempt wasn't in vain. You can kind of see like why it doesn't work, but still, I'm so sorry. Okay, so after the squared term, now I'm going to include the negative x term, and then my constant term. And then over here, we're going to have x squared minus x plus 1. I should have reviewed a little bit before I started this video. Duly noted, lesson learned. All right, now let's try this again. So I'm going to kind of breeze through this a second. So x squared, which is going to give me x to the 4th minus 4x cubed, and then plus x squared. There we go. Now everything's matching up. So we have to be able to combine like terms. So x to the 4th, these are going to cross out. I can combine those. The x cubes, I can combine those. Oh my gosh, I messed up math again. Math is hard, y'all. I'm so sorry. Oh, Lord. Okay. Take 3. So x to the 4th minus x to the 4th, 4x cubed minus negative x cubed, and then 0x squared minus x squared. There we go. Everything matches up. So those exponents, they have to match up. Also, I just noticed I have green and red. Merry Christmas. Ho, ho, ho. So now we're going to have 4x cubed minus negative x cubed. So that's going to be minus a negative, which is going to be 5x cubed. And then the next one, we're going to have 0x squared minus x squared. So that's 0 minus 1, which is negative x squared. So now for the next set, so I'm going to bring down this negative x. So once again, we're only going to pay attention to our Reginas. So x squared times what is going to give me 5x cubed. So when I get here, well, that's going to give me plus 5x. Now I'm going to take that 5x and then multiply it times my divisor, write it underneath, and then we're going to subtract. So that's going to give me 5x cubed minus 5x squared plus 5x. Okay, and then we're going to subtract. So the 5x cubes are gone. Now I have a negative x squared minus negative 5x squared. So this is going to turn into negative 1 plus 5, which is 4. So we're going to have 4x squared. And then over here, we're going to have negative x minus 5x, which is going to be negative 6x. So minus 6x, and then that completes that cycle. So I'm ready to bring down this 1. So the same idea. So x squared times what is going to give me 4x squared. So the x squared's already there, so I just need the 4. So multiply, so this is going to give me 4x squared minus 4x, and then plus 4. All right, now when I do the subtraction, so the 4x squareds are going to cross out. So negative 6x minus negative 4x, so negative 6 plus 4x, which is going to be a negative 2x. And then we're going to have 1 minus 4, which that's going to give me a negative 3. Okay, so now that I have all my components, I've got my divisor, my quotient, and my remainder. Now I'm ready to write my polynomial in terms of the division algorithm. So when I rewrite it, so over here, so I'm going to have my quotient, which is x squared plus 5x plus 4, and then times my divisor, so x squared minus x plus 1. Oops, try not to get too sloppy here. Okay, and then I'm going to add my remainder, which is going to be a negative 2x minus 3. Now when you get here, we do want to clean this remainder up over here. So this is just going to be x squared plus 5x plus 4, and then x squared minus x plus 1 minus 2x minus 3. So this is how AP will likely write it. Ooh, sorry y'all, that one was a bit of a roller coaster for me. Okay, so this entire page is really just extra practice, but I do want to do even just kind of a couple problems just to kind of show you a couple tricks with synthetic mostly. For the long division problems, I'm just going to do those two, but I do want to show you some tricks with synthetic. So, namely, let's look at number 6. So when I look at number 6 here, I'm still dividing by a linear. However, your value, your slope here is not 1. So it makes synthetic division a little bit more tricky, but it's still the same idea. So let's take your divisor over here. We're going to set that bad boy equal to 0. So 5x minus 2 equals 0. Now you add 2 and then divide by 5. So that's going to give you an x value of 2/5. So that's what I'm going to use for my synthetic. So we're still going to follow the same general steps. Now I'm going to write my coefficients of my dividend. So I'm going to double check and make sure I write this correctly. So to the third power, second power, to the first power, and to a 0 power. I don't have any 0 coefficients I need to keep in mind. And then everything's in order, so I can just copy them down. So 10, negative 29, negative 5, and positive 6. I don't know why I drew that line so low. Let's move you up a bit. Okay. So once again, bring down. So we have 10. So once again, when it's working with the diagonal, we're going to multiply. So we're going to have 2 times 10, which is 20. 20 divided by 5, which is 4. So that's going to be my next value. And then we're going to add these numbers together. So negative 29 and positive 4 make a negative 25. So now negative 25 times 2 is negative 50. Negative 50 divided by 5 is going to be negative 10. Add these numbers together, so that's going to give you negative 15. And then negative 15 times 2 is negative 30. Negative 30 divided by 5 is going to give you a negative 6. So we get 0 here. So once again, I'm going to start with my remainder, 0 power, first power, and my second power. So when I look here, this is technically going to give me 10x squared minus 25x minus 15. So if I just circle this and say, ta-da, that's it, unfortunately, you're actually missing a step. And that's because we have to account for this 5 right here. So if I look here, if I try to multiply these two values together, that does not give me the dividend. Because 5x times 10x squared, that's going to give me 50x cubed, not 10x cubed. So when you have a fraction over here, what you're actually going to do is you're going to take your entire value here, your quotient rather, and we're actually going to divide it by whatever denominator value we have, which in this case is going to be 5. So all these entries are going to get divided by 5. So that answer is going to give you 2x squared minus 5x minus 3. So this is actually your result when you do synthetic with a fraction. So I'm going to rewrite this using the division algorithm. So my division algorithm over here, so it's going to be my quotient, which was 2x squared minus 5x minus 3. And then you're going to multiply that times your divisor, which in this case was 5x minus 2. And then we don't have a remainder, so we don't have to worry about adding anything else. Okay, so now let's look down at 7. So I actually invite you to try this one on your own. So pause here, and then we'll try it. Okay, so looking at this one, so I'm going to take my 3x minus 1, set it equal to 0. So when I solve, we're going to get a value of 1/3. So I'm going to use my 1/3 in my synthetic. And then when I do my setup here, what's going to happen, notice how your dividend here is going to be out of order. So I need to start with the high power. So my first value is going to be coefficient of 6, and then my coefficient of 1, and then my constant term, which is negative 1. So 6, 1, and negative 1. So this would be the order in which you write your values. So here is your synthetic setup. So bring down your 6, and then multiply. So 6 times 1/3, you're going to multiply these values, which gives you 2. Then add, and you get 3. Multiply, you get 1. Add, and you get 0. So based on the setup, this would be remainder, constant, and then the first value, which is going to give me 6x plus 3. But because we have a fraction in synthetic, we're going to divide by whatever your denominator value is. So when I divide all this by 3, so that actually means we're going to get a value of 2x plus 1. So when I write it using the division algorithm, so you're going to get your quotient, which is 2x plus 1, and then multiply times your divisor, which is 3x minus 1. Ta-da! Okay, and then just a few little notes about 8, 9, and 10. I'm not going to do those because you've already seen me do some long division, or synthetic also. When you get here, just, my brain stopped working. Make sure that they are written in descending order. Make sure you're accounting for any 0 coefficients when needed. I don't think any of these have 0 coefficients, just this one up here. So as you saw from my horrendous and heinous mistake that I made up here, you're going to see that it's not going to work if you are not abiding by those division rules. Which those division rules, I do have them up here, which ironically enough, I did not remember to do. Or rather, I didn't check, but yeah. So, ta-da, make good choices.